Starting a career in data analysis is exciting, but many beginners get overwhelmed by the sheer volume of tools, programming languages, and mathematical concepts they are told to learn. They often waste months studying advanced topics like machine learning or complex neural networks, only to discover that entry-level job roles require practical, foundational skills. Navigating this learning curve does not require a computer science degree or mastering dozens of software applications. It requires a structured, step-by-step path that focuses on the core competencies employers actually hire for. This video provides a clear, practical roadmap for aspiring data analysts. We will break down exactly what skills to learn first, how to prioritize your study time, and how to build a portfolio that demonstrates your capability to solve real business problems. By the end of this guide, you will have a clear plan to build your analytical skills. First, let us establish the foundation of your data roadmap: spreadsheet mastery. Many beginners overlook spreadsheets, believing that SQL and Python are the only tools that matter. This is a critical mistake. In almost all business settings, spreadsheets are the default medium for quick analysis, team collaboration, and executive reporting. Before you write a single line of code, you must learn how to manipulate, clean, and summarize data in Excel or Google Sheets. Focus on mastering key functions such as sumifs, countifs, lookup, and nested if statements. You should also learn how to build pivot tables to group data and build dynamic charts that show business trends. Spreadsheets are ideal for learning the core principles of data structure, such as rows, columns, data types, and logical relationships. They also force you to think about how your analysis will be presented to others. A professional who can build a clean, well-organized dashboard in a spreadsheet is far more valuable to a business than a coder who writes confusing scripts. Spend your first few weeks of study mastering these spreadsheet basics. They are the most frequently used tools in any analyst's daily workflow, and they provide the logical foundation you need before moving on to database languages. In fact, many senior analysts continue to use spreadsheets daily because they are the fastest tool for ad hoc calculations and client presentations. When you master spreadsheet shortcuts and advanced formatting, you can complete tasks in minutes that might take an hour to write in Python. Furthermore, spreadsheets allow you to visually inspect your data at every step of your calculation, which helps you spot outliers and formatting errors immediately. This visual feedback loop is highly valuable for beginners as it builds a strong intuition for data behavior. Do not rush past this stage. A deep understanding of spreadsheet logic makes learning database querying languages much smoother, as the underlying concepts of filtering and sorting are identical. Spend sufficient time practicing formulas until they feel natural. Second, once you are confident with spreadsheets, your next major milestone is mastering SQL, or structured query language. SQL is the industry standard language for communicating with relational databases, where companies store their primary transaction records. As a data analyst, you will spend a large portion of your time extracting raw data from databases, making SQL an essential skill. Fortunately, you do not need to learn database administration to be effective. Focus on the core querying syntax first. Select statements to pull columns, where clauses to filter records, group by clauses to aggregate metrics, and order by clauses to sort results. Additionally, you must master SQL joins, which allow you to link separate tables together using matching key columns. Understanding how to write inner joins and left joins is crucial, as business data is routinely split across multiple tables. To practice SQL, you do not need to install complex database software. You can use free online platforms that offer interactive environments with sample datasets. Practice writing queries until you can confidently answer business questions, such as identifying top-selling products or calculating monthly customer retention. SQL is highly valued by employers because it allows you to access raw data directly without relying on others to export files for you. When learning SQL, pay special attention to the order of execution, which is different from the order in which you write the code. For example, the database processes the from and join clauses before filtering with the where clause, and only applies the select statement near the end. Understanding this internal order of operations prevents logical errors and helps you write more efficient queries. Additionally, practice writing clear, readable SQL code by using proper indentation, uppercase letters for syntax commands, and descriptive table aliases. This makes your queries easy for other analysts to read and review. Writing clean code is a key professional habit that will set you apart during technical interviews. Mastering these syntax patterns ensures you can query databases with speed and precision. Finally, you should learn the basics of data visualization tools and how to package your work into a professional portfolio. Once you can extract data with SQL and analyze it in spreadsheets, you must learn how to communicate your findings to non-technical stakeholders. This is where business intelligence tools like Tableau or Power BI come in. You do not need to learn both. Pick one and master the basics of building clean, interactive dashboards. Learn how to design layouts that guide a viewer's eye to key performance indicators, use color schemes that highlight trends, and add filter controls that allow users to explore the data themselves. Once you have built a few dashboards, package them into a portfolio. A strong portfolio contains 2 or 3 detailed case studies where you explain a business problem, show how you gathered and cleaned the data, and present your final recommendations. Store your SQL queries and dashboard links in a clean repository like GitHub, and write a clear summary of your findings. This practical evidence of your skills is what employers look for when hiring. By focusing on spreadsheets, SQL, visualization, and a solid portfolio, you build a practical skill stack that prepares you for entry-level analyst roles. When documenting your portfolio projects, focus on the business impact of your work rather than just the technical tools you used. For example, explain how your analysis helped reduce delivery times or identify a new customer segment, as this demonstrates that you understand the business context of your data. Share your project summaries on professional networking platforms and seek feedback from experienced practitioners. This active engagement helps you refine your presentation style and expand your network. Remember that technical skills are only half of the equation. The ability to explain complex findings in simple terms is what makes a truly successful analyst. By following this structured roadmap, you avoid the trap of learning random tools and instead build a cohesive capability profile that aligns with market demand. Data Skills Sprint teaches practical data skills for beginners and busy professionals. We break down spreadsheets, SQL, dashboards, automation, and analyst workflows into short, clear lessons. Every video is designed to help you learn one useful skill and apply it immediately at work. This video is general data education, not a guarantee of career placement, salary increase, or software certification. Code syntax and software UI change over time.